What's up, math magicians? We are going to talk about interval notation, domain, and range of graphs today. We're also going to throw in some domain and range of functions because it's important. You got to know that stuff. You can't just go your whole life without knowing domain and range of functions. So we're going to throw that stuff in there too at the end. But I pared down the notes. Hopefully these ones aren't 40 minutes or something insane like that today. So we'll try and get through it, no nonsense. All right. Let's talk about vocabulary first. So we need to tell you what domain and range are. Let's look at a graph. That's not how you write. Clear that. Change this to blue. Make that thing skinny. Let's look at a graph. If you have a graph like this, and let's take the dot off, the arrow off of it. It's this, and it stops there and there. The domain and the range can be thought of kind of like a box around this graph. So we draw a little box that just barely holds the whole thing. You don't want to make it bigger than it has to be. Your domain is the set, and set just means list in math. It's a group of things of all the x values inside this box. So if we look at the x-axis, this box goes from there to there. So our domain is all of those numbers. Likewise, the range is all the y values in that list. So our box goes from here to here. Our range is that. All right, cool. So that's what we're going to be focusing on today is what is this list and this list, or what are these lists? And we're going to write them in two different ways. The first way is going to be set notation, though this is one that we are going to gradually transition away from. I prefer interval notation because it's a little more compact and then I don't have to remember how these things work. But I mean, you should know anyway, so we'll learn this one. So we're going to use inequalities to determine where a function's domain and range exists. And it should have an apostrophe there, possessive function. So this is just an example. This would mean x is, because this thing is facing the x, it's saying x is bigger than the negative 3. So x is bigger than negative 3. But because it's facing, this one's facing away from the x is smaller than this number. So this is saying x is bigger than negative 3, but smaller than 5. That's its way of saying negative 3 to positive 5. And because this has lines under it, it says it can equal it. So it includes that point and it includes this point. Okay, we'll practice this. The other way that we're going to learn how to say what the domain and range of something are is by, sorry about that, I had to yell at my dog. So the way that we're going to say our domain range another way is interval notation. So this is just a different way that we can write it. And basically what we're going to do is we're going to cut out all of this middle stuff. And we're just going to leave the two numbers, and then we're going to use either brackets or parentheses to show whether or not we are equal to those numbers or not quite there. So let me show you how that works. Okay. The thing you need to know is that if we are including the number, it will have a filled in circle, and we're going to use brackets. If we don't include the number, it'll have an open circle like that, and we're going to use parentheses instead. Okay, so let's look at some examples. So here we have a number line graph, and we are trying to say that our domain is going to go from negative 2 to 4. And because these are filled in dots here and here, we're going to include the endpoints. So let's talk about set notation first. We're going to put x right in the middle every single time. And then we're going to put a less than and a greater than. or actually these are two less thans, but you get what I'm saying. One facing towards the x and one facing away. The smaller number is negative 2. So all these numbers here are bigger than negative 2. This is the x stuff here. So x is bigger than negative 2. But x, the stuff in the middle, is smaller than 4. So this is going to open towards 4 because it's bigger than x, and away from negative 2 because x is bigger than negative 2. Now the way that we're going to show that these are closed and that we're including the ends is we put lines under these to say or equal to. So that's set notation. Let's talk about interval notation. Interval notation I think is a bit easier. For interval notation, we want to say start at negative 2 and go to 4. So we just put the numbers, negative 2, comma, 4. Then we need to say, are we including the ends? Because they're filled in, we're going to include them. Filled in circles get brackets. So brackets are just like square parentheses. And there we go. All right, they're also going to ask you to go the other direction. So they're going to have the set notation, and then you have to write the interval and make a number line graph. So x is bigger than negative 3, so we're going to start at negative 3. Because there's no line under here, that means x can't equal negative 3, so we're going to put an open circle. Likewise with 10, x is less than 10, so it's going to go up to 10. So 7, 8, 9, there's 10. We're going to put an open circle because there's no line under to show or equal to. And then x is in between them. X is bigger than negative 3 but smaller than 10. Bigger than negative 3, smaller than 10. So we're going to connect the two lines, or two circles rather. So there's our graph. To make this in interval notation, we're going to cut out the middle, and we're just going to say the two numbers, negative 3 to 10. Because these are open circles and it's not equal to those, we're going to put parentheses instead. So parenthesis, parenthesis. All right, cool. Let's look at some more challenging examples here. So here we have a line. It's got arrows on both sides. And then it's got this big hole in the middle at 1. So let's start with our set notation. So this goes to negative infinity, right? Negative 7, negative 8, negative infinity. It keeps going left forever because of the arrow. So we're going to say that, actually hold tight. We'll think about that, okay? This thing also continues on to positive infinity, and there's a hole at 1. So we're going to say x is less than 1. This is x right here. This is all the stuff smaller than 1. And then we don't need to stop it, right? We just let it keep going. X is less than 1. Cool. X is also all of this stuff over here, and it keeps going forever. So x is also greater than 1. Okay. We can't really connect these because, there's a hole in the middle, so there should be a break. Okay. This would be our set notation. For interval notation, anytime you have multiple chunks, we have a chunk from negative infinity all the way to 1. That's one chunk. Then we have a second chunk from 1 to infinity. Anytime you have separate chunks with a gap, even if that gap is only one spot, we have to make separate intervals. So we're going to say this interval first. It starts at negative infinity. It just goes that way forever. And then it keeps going until this break. And this break happens at 1. We're not including the 1. There's an open circle, so it should get a parenthesis. Now you're going to say, Mr. Barner, we're including the negative infinity, right? So it should get a bracket? Don't write that. The answer is no. Negative infinity is not a real number, You can't get there. If I said, hey kid, go walk infinity miles north, or I point in a direction, I give you a spaceship. I say, go infinity that direction. You're going to get in your spaceship, and then you're going to fly away. You're going to spend the next 70-something years floating around in your spaceship, reading books, playing video games, but not online because there's no Wi-Fi in space. You're going to spend the rest of your life on that spaceship. You might even take a wife or a husband, someone to reproduce with. So you're going to die in that spaceship. Don't worry, you're going to have kids. They'll carry on your legacy. Are you going to get to infinity? No. Okay, let's say your kid takes up the mantle and your kid goes, don't worry, mom or dad or non-binary parent. I'll go to infinity. So your kid spends their whole life trying to get to infinity. Is it going to happen? No. And let's pretend you somehow find someone outside your family or your kid finds someone outside your family for them to marry and reproduce with. Are they going to get to infinity? No. And neither will your grandkids or your great-grandkids. So the point is you cannot get to infinity, so you can't include it. So you put a parenthesis. That's the long way of saying infinities always get parentheses. Infinities, positive and negative, always get parentheses. Okay. Next chunk starts at 1 and goes to positive infinity. We can't go to infinity, parenthesis. Are we including 1? No, open circle, parenthesis. So this would be our interval notation. Because we have 2 intervals, we also have 2 sets of inequalities. All right, here's another graph. Just for the sake of showing you that it's possible, let's pretend that this -1 is filled in. So we're going to need 2 intervals because we have 2 chunks, all right? We got this chunk, we got this chunk. So let's do this chunk first. It goes from -5 to -1. The -5 is not included because it's an open circle, so it gets a parenthesis. The -1 is included, though, because we have a filled-in circle, so it gets a bracket. Now we need a second interval for this chunk here. So we're going from 2 to 6. And because they're both open circles, they both get parentheses. Let's do set notation. Here, x is in between 2 numbers. It's this chunk here. So we're going to have x in between 2 inequalities. The smaller number is -5, so that goes on the left. X is bigger than -5, but it's smaller than -1. The -1 is also filled in, so the -1 inequality should get a line under it. Now we need the set notation for this chunk. X is in between 2 numbers, so x goes in between 2 inequalities. Goes from 2 to 6. 2 is the smaller one, 6 is the bigger one. And they're both open, so neither one of them gets the line under it. And there we go. There's set notation, interval notation, and number line graphs. Now you're going to say, Mr. Barton, number line graphs are for babies, and I'm not a baby. Let me do a big kid graph with an x and a y axis. All right, you asked for it. So we are going to talk about the domain and the range. So let's go ahead and put domain, range, domain, range. Okay. When you're doing this, what I recommend you do is draw a box around the graph, and you want to only go as far as you have to. So you could draw a box like this. Okay, but there's all this wasted space over here. There's all this wasted space up here, down here, and down here. So that's no good. You're wasting too much space. Okay, tighten that thing up. You want to just find the highest point. Oh no, I accidentally erased my endpoints. Okay, you want to find the highest spot right here, the farthest right, the farthest down, and the farthest left. Make a box out of that. Okay. Now, our domain goes with the x-axis, and our range goes with the y-axis. So let's look. How much of our x-axis is included in this thing? Okay, well, right there. We go from negative 1, 2, 3, all the way over to 1, 2, 3. For our range, we go down negative 1, negative 2, and then up 1. You always want to go from smallest number to biggest. Okay, it should always be in this format, right? Maybe parenthesis, maybe bracket. Now we have to figure out, do we use parentheses or brackets? So this point here is filled in. That's the point that makes me go all the way to the left. So we're going to use this point to determine if the left side should be filled in, or rather if it's a bracket or a parenthesis. Because it's filled in, it gets a bracket. This point is also filled in. That's what makes me come all the way over here. So it gets a bracket as well. All right. Now for range, we're talking about the y-axis. Let me even change colors. Let's do purple. -2 to 1. And we're talking about this part here. So the top part, you're going to say is, I don't see any filled in or open points. If there aren't any, assume they're filled in. This is a solid line, so you get to include it. So the high number, 1, that's solid, so it's going to get a bracket. And then our bottom point, the lower bound here for our range, this is also a filled in point, so it also gets a bracket. Okay. So now for domain. We're going from -3 to 3, so we're going to put x from -3 to 3. It's a bracket, so we're including it. So x can equal both those, so they should have lines under them. For range, we're going from -2 to 1. Are we graphing on the x-axis, though, if we're going up and down? No, we're using y, so we should have a y in there. These are also brackets, so we are including this. It equals that, and it equals that, so we put the or equal to underneath. Okay, let's do a couple more of those just to make sure we understand. So here's our graph. We're going to put domain, range, domain, range. We're going to draw a box around this. So here's the bottom, here's the top, here's the farthest left we go, here's the farthest right we go. Okay. Now we want to figure out what part of the x-axis is included. This goes from -1, 2, 3 to the right 1, 2, 3, 4. Okay. The left side, this point is filled in, so we're including it, and it gets a bracket. This point on the right, though, is open, so it's kind of saying there's a hole there. You're avoiding it. It's not included, so the right side should get a parenthesis. Now if we're looking in the y direction, for our range, we want to know what's included in our square. So it goes from -2 up to 1, 2, 3, 4. The very bottom point that makes our box go down that far, this is filled in, so it gets a bracket. The highest point, that's open, so this gets a parenthesis. Now we have to do set notation with our inequalities. Domain is x. We're going to put less than, less than. It goes from -3 up to 4. This has a bracket because it's including that, so it can be equal to. The 4 has a parenthesis. It's open, so it can't equal that, so we just leave it as a less than with no line under it. For range, we're not talking about x, we're talking about y. Less than, less than. The lowest we go is -2. The highest we go is 4. We're including the -2, so we get a line under that one. We're not including the 4, so we leave it underlined. No line underneath. All right, let's do one more weird, challenging one. So we'll do domain, range, domain, range. All right, let's draw our line, our box. So here's the top. It's going to go like this. Here's the farthest right. Let's go up that way. There we go. Connect those. This is also the bottom. And then here's the farthest to the left. Okay. So now let's look at our domain. We want to know how much of this x-axis is inside of our box. So we're going to do that. So it goes from -4 to the right to 6. This point is open, so we're not including the 6, so it gets a parenthesis. The 4, the -4, solid point, so it gets a bracket. All right, let's look at range. Let's switch to green. Let's do a darker green. Here's the top all the way down to here. Remember, we want to start at the bottom, go up. It should be smaller number than bigger number, or more negative than more positive, I should say. So the lowest we get is -5. The highest we get is 1, 2, 3, 4. This -5, that's open, so it gets a parenthesis. On the top, we don't have a dot to compare to, right? There's no open or closed dot here. So we get to assume that it's closed. If they wanted it to be open, what they would have to do is they would have to get blue. They'd have to put an open circle there to show, hey, there's a hole here. Do not include it. Because there's not a hole telling us not to include it, we're going to just assume we can. So this 4 is included and it gets a bracket. All right, set notation. Let's put our x in the middle, less than, less than. The smallest it gets is -4. The biggest it gets is 6. The -4 is included because it's closed in, so it gets a line under it instead of a bracket. The 6 has a parenthesis, so no line. For range, we're not talking about x, we're talking about y. Less than, goes from -5 to 4. The 4 has a bracket because we're including it, so we put a line under it. And there we go. Let's talk about one more type of graph really quick. Domain, range, and I'm just going to show you interval notation. But let's imagine a graph like this. Okay, let's say it starts at 2, 1, and then it has an arrow. What do we do if there's an arrow, right? Because our box is kind of hard. Can you draw a box around something that goes on forever? Not really. So here's the farthest left it goes. Here's the farthest right it goes. Okay, I can't come up here. I can't draw a right side. Because if I draw a right side, well, this graph doesn't stop here. It keeps going, and then your right side would get pushed out. So we're just going to leave it blank. Okay. All right. So let's see what's included in this thing. For our domain, well, the farthest left we go is right here. Where is that? That's at 1, or at 2, excuse me. And then what's the farthest right we go? There's no right wall, so it's way over there at infinity. So we're going to put infinity. This point is filled in at 2, so it's going to get a bracket. But the infinity, we can't get to infinity, so it gets a parenthesis. For range, all right, what's the lowest we go? Here's the lowest. It's right there at 1. And there is no top. It keeps going up forever too. So it also goes to infinity. So we put infinity. You can never get to infinity, but we do touch 1. So that's how you would handle it if you have an arrow. If you have an arrow, you're going to have infinities. Okay. Just so we're 100% clear here, if you had something like this, then you would have negative infinities because it goes down forever, and down is negative. It goes left forever, and left is negative. So that would be negative infinity, and this would be negative infinity. All right. So that's graphs. One more thing we have to talk about, and then you are going to go do some homework, and you're going to love every minute of it. All right. We want to know, what is the domain of this thing? So first we have to talk about, there are 2 rules in math that we can't break for now. The first rule is you cannot have a negative inside a root. No negatives in roots. Okay. The second rule, rule 2, is you can't divide by 0. No dividing by 0. Okay. So if we look at this problem here, we don't have any dividing, so we don't need to worry about this rule for right now. But we do need to worry about this rule because you could accidentally plug in a number that makes this 0, right? If x is negative 100, then we're going to have 5 times negative 100 plus 8. That's negative 500 plus 8. That's negative 492. Oh no, we have a negative inside our root. That's bad. So we can't have that. So clearly negative 100 is too negative. But if you plug 1 in, 1 times 5 is 5, plus 8 is 13, that's fine. So somewhere we go from being okay to not being okay, and we need to figure out what that is. So let's talk about how we're going to do that. You're going to take the radicand. Let me write that down. Radicand. What that means is just the inside of the square root. So we're going to take the inside of the square root plus 8. And it has to be positive or 0. So if it's positive, all right, let's talk about the is 0. Is 0 means equals 0. If it's positive, is it bigger than 0 or smaller than 0? Bigger, Mr. Barton? Oh, okay, thank you, kids. Bigger. So if this is bigger than 0, that means we need an inequality. So you're going to take the radicand is greater than or equal to 0, and then we're going to solve for x. So let's do that. So let's subtract 8 on both sides. The 8's cancel. 5x is greater than or equal to negative 8. Then we're going to divide by 5. These cancel. X is greater than or equal to negative 8 over 5, or as a decimal, this would be negative 1.6. Okay, so our answer is either x is greater than or equal to negative 8 over 5, or x is greater than or equal to negative 1.6. This is your domain. We could also write this in interval notation. So x is bigger than that. So it can be 1, 2, 3, 4. Those numbers are all bigger than this. This is the smallest it can be. So we would say the smallest it can be, negative 1.6, to the biggest. Well, there is no biggest. It can just be as big as it wants to be. So infinity. Bracket, because it's or equal to. So we could either write it in interval notation like this, or in set notation like that. Okay. Let's talk about the domain of this thing. So now we don't have any radicals, so we don't need to worry about having a negative inside, but we are dividing. So we have to worry about the dividing by 0. That's bad, right? So the way we figure out what number this would be is we take the denominator and we set it equal to 0. So x minus 7 equals 0. We're going to solve for x. So plus 7. These cancel. X equals 7. This is what's called a restricted value. Because if I plug this in, 7 minus 7 is 0, and then we're breaking a rule. So that means we're going to say, don't use this. Put a line through that. This is one way that we can write our domain. We can, instead of saying all the numbers it can be, we can say, don't use that one. I have a feeling this is not how your homework looks, though. So we have to write it in either set notation or interval notation. So let's draw a number line graph to just illustrate what this looks like. It can't be 7. So here's our number line. Here's 7. It can be all the numbers bigger than 7, like that. It can be all the numbers smaller than 7, like that. But it cannot be 7. So there's a hole on 7. So this is the number line graph. So we need to say the interval or set notation for this thing. So interval notation, we have this chunk here. So it would be from negative infinity to 7. Don't include 7 because there's a hole. Don't include this because it's an infinity. And then we have this chunk here, which starts at 7 and goes to positive infinity. Parenthesis, because it's infinity. Parenthesis, because there's a hole. This would be our interval notation. Likewise, we could put this in set notation. We could say x is all the numbers smaller than 7. X is less than 7. And all the numbers greater than 7. X is greater than 7. And that would be your set notation. One more and then we're done. And this one you don't even have to do. So let's look at this one. Is there a square root? No. So I don't have to worry about there being a negative in a square root if there is no square root. You can't shoot yourself in the foot if you don't have a gun, right? Is there dividing? No. So you can't cut your finger off if you don't have a knife, right? So if I don't have to worry about the square root and I don't have to worry about dividing because neither of those things are in the problem, there can't be anything wrong. So any number in the whole universe will work in this. So this one, any number works. The way we say that is the domain is all real numbers. Okay. There's a symbol for this. The symbol for all real numbers is a capital R, except this left bar has 2 lines. So you might see it either way. It might either be the phrase all real numbers, or it might be the symbol for all real numbers, the double R. All right, so there you go. Now you know about domain and range. Now you are all set to do your homework. So if you have questions, go get in the WebEx. When you get in the WebEx, do your homework. I'm tired of you darn kids skipping out saying, you know what, I'm going to go smoke cigarettes with my friends behind the Circle K. Heck, homework. I'm not doing that. You need to do your homework, otherwise I'm going to call your mom. All right, I'll see you guys next time.